Okay, so today we are going to discuss about the topic is Snowflake tasks. So what is mean by tasks in Snowflake? And basically we'll cover today like a overview of these tasks and how these tasks will run, what is mean by tasks DAG, and how these tasks are going to be scheduled and how we are going to troubleshoot these task failures. So
Okay.
we are going to discuss today as part of these items, as part of this session. Today's session we are going to discuss about these items. Okay, so now first we'll see what is mean by task in a Snowflake. So basically we are discussing about Snowflake tasks objects, right? So basically like there are, we have seen several objects are available in Snowflake. So we are going to deep dive into each object. So far we have already covered about views, tables, stages, file format, all these objects we have covered. So now we are going to discuss about one more object which is called as a task. So why we need this task? What is mean by task? So in a simple terms, task is nothing but a job scheduling tool in a Snowflake. So job scheduling in the sense, if you want to run something repetitively, if you want to schedule something on so and so date, so and so time, you want to execute some particular command. By using this task, you can s- achieve that. So this, in a nutshell, I would say Snowflake task is a kind of a job scheduling tool in a Snowflake side. So now ideally, if you go to the legacy systems and all, so you need to use some third party tool to schedule the jobs. But now coming to the Snowflake, it is a complete data warehouse solution they're providing, right? So you don't need to go, you don't need to depend any other third party. Everything will be available inside the Snowflake. So now you can use this task and you can do your job schedulings, everything, whatever you want. So now if you see, the task object defines a recurring schedule for the executing a SQL statement, including statements that the call store procedures. So what it means, now if you want, I have some insert statement is there, or else I have some merge statement is there. So I want to execute that merge statement repeatedly every 5 minutes or every 10 minutes or every 1 hour or daily once. So now if I want to run that particular SQL statement, it could be anything, either DDL, DML, whatever it may be. If you want to run repeatedly that one, so you need to like run manually, ideally if you want to execute that particular statement. But in Snowflake tasks, they're providing a feature, so you can schedule this task, and as part of the task you can define this particular, either it could be store procedure or it could be SQL statement. It will automatically, the task will execute and it will perform that particular action. Okay, now the tasks can combine with for continuous ELT workflows to process recently changed table rows. So this is what, like when we are talking about data warehouse, something we need to come into the picture is like always you are bringing the data from multiple sources and you are placing the data into the data warehouse. It is the main functionality of the data warehouse as a data engineer, as a data warehouse developer. So now when you are bringing this data, maybe if you have some ETL tool, you are going to extract the data and you are bringing the data into the Snowflake, and then on top of that you are going to do your use cases. But as I mentioned, modern data warehouses all are adapting the ELT workloads. ELT in the sense, after loading the data into the data warehouse, that's where you are going to do the transformations. So now already we have discussed in Snowflake, not only Snowflake, wherever you go, whatever the data warehouse, there would be definitely multiple layers will be there inside the data warehouse. For example, if you take a staging layer, integration layer, presentation layer, this is what from starting onwards we are discussing, right? Commonly. So first we'll bring the data into the staging or raw layer. From there, you will do the transformations and you will load the data into that INT layer. On top of that, you are going to create a views. So that is the kind of a workflow we were discussing from starting onwards. So now if we take a same example, so after loading the data into the staging area in Snowflake, you are going to do the transformations as per the business need. So all these transformations, like if you want to do it manually, you need to write a SQL queries or like you need to put all these SQL queries as part of a particular procedure we call. So you need to schedule that, like, okay, now every day at 6 o'clock, data is coming to the stage table. Now I want to do the transformations and I want to make it available the data in PRS layer by 10 o'clock. So the business report, they're using a Power BI and they have a scheduled job at their end. Every 10 o'clock, they'll connect the Snowflake PRS layer and they will try to pull the report. Okay, so by the time you need to make it available this data into the PRS layer. So in PRS layer, we know like we are creating a views, but before that, we need to make it available the data into the INT layer. So now let me take an example, then you might get some more clarity. Please go on mute, guys. These are my source systems. Now I'm bringing this data into the data warehouse. So inside this, I have a staging ANT PRS. So now this is a kind of a stage. Top of this, this is a business intelligence team. So they'll connect to this PRS layer and they'll try to consume the data as per their business needs. So they don't have access for this INT and stages layer. Ideally, in real-time projects also, we won't provide access. We'll provide only access to this presentation layer. So now this is a kind of a data warehouse. Okay, so now every day at 5 o'clock, I'm bringing this data into this particular staging layer. So just assume it's coming as a 5 p.m. So now I want to make it the data available in here by 10 p.m. so that this team, they'll run the job at their end at 10 p.m. or 11 p.m. These people are running the job at 11 p.m. Okay, so now there is a 1 hour kind of a buffer time we are keeping it. So since they are running at 11 o'clock, we need to make it at least maximum by 11 o'clock, but we'll put always target as a 1 hour backup. If something goes wrong, then we can use that 1 hour and we can make it available by the time. But always we'll target as a 1 hour before that. So now if this data is coming here at by 5 p.m., now I need to do the transformations, and then finally I need to make it available the data into the final layer. By 10 p.m. So now if I want to do these transformations on timely basis, if you want to do kind of a manually, what you need to do, you need to every day sit one dedicated person here, and we need to monitor the data is already available or not in the staging table. Then we need to execute the transformations logic, and once the data is available here, then we need to create a view and we need to make it available the data into the PRS layer. So these are the action items I want to do as a person manually. Then only this particular people they can able to read the data, consume the data from PRS layer. So now for example, take like a sales data is there. So now sales every day we are going to having the sales. So now we every day we are going to bring the data into that particular the staging layer. So now as a business user, they want to see the kind of a total sales, not like individual transaction details, right? They want to see aggregate values. So now since you are bringing like all the date details and sales details here, what you want to do, you need to do that accumulate aggregation for that particular date and particular sales. Then you are going to populate the data into this particular PRS layer. Then these people they run the report at their end. This is a kind of a on timely basis every day you need to do. So if you want to do this, there is a kind of a dedicated person needs to be sit during this window, and you want to execute all these queries manually. Otherwise you need to use a some job scheduling tool, and you need to execute that logics on timely basis. Okay, at 5:30 should execute this logic, at 6:30 should execute this particular logic. Then finally by 7 o'clock you need to create the final int table. Then 7:30 we need to create a PRS view. Then the business can consume the data. So in PRS there is no guarantee like always you will create a views. You can create a tables also. There are certain cases will be there, but ideally the recommend approach is we'll create a views here in PRS layer. So now since as I mentioned, Snowflake is providing the task facility. By using the task, you don't need to sit any dedicated person. You don't need to go with any other third-party job scheduling tool. You can execute those logics during this time period. You can schedule basically the task for this particular time period so that the tasks automatically will execute and it will make it available the data into the final layer. Then this particular business consumers, they can consume the data. Is it clear? Any doubt?
So this task process will be automated, na?
Yes.
And this task process is similar to what we read yesterday.
No, I mean similar in the sense I didn't get your.
Like like yesterday, we wrote a code and then we did the staging of the data. So the entire process of staging of data will be automated.
Not staging. So now like if you are bringing that, let's say business logics, if you are doing kind of aggregations and all, see we have did a staging and we placed the data into the staging. From the staging till this PRS layer, everything can be taken care by the tasks.
Okay,
Staging is something is like you are placing the files into the staging layer, right?
correct.
From there you need to run the copy command and you need to make it available the data into the table. So now if you kind of adding that particular functionality here, so now extracting this data, converting this data into that CSV file, and we are going to place that files into that. Ideally in the real-time projects, most probably will go with the external stages. So now all this data will be there in external stage. For example, just assume here I have a be AWS or Azure, GCP. So these are the three cloud platforms as of now Snowflake will support. So now I'm just using any one of these particular cloud platform. I'm going to place this data in the form of CSV here. Okay. So now my data is available in this external stage. So now from here onwards, I need to load the data first into the stage table. Then I need to do the transformations logic and make it available that INT layer. Then finally, I need to make it available the data into the PRS layer. So this everything, this entire workflow can be taken care by the tasks.
So how to create that kind of task, sir?
That we need to discuss it, right?
Sir, the external stage you were supposed to teach today. Did I miss it?
No. External stages we will cover next class. So that is a dedicated session is required. We need to do that environment setup and done. So now as part of this, I'm trying to explain about the tasks functionality. So now by end, we will connect all these bits and pieces. So if you want to, like in a single shot, if you want to everything, it is not going to be digest and you are not going to be understand what is the functionality. So yesterday we have seen internal stages and all, right? So now we are talking about the tasks. So the tasks will come into the picture here inside the Snowflake. So we will see about the tasks functionality, how it will work first. Then we will see about the external stages. Then we will connect how this external stages is linked with the tasks and all. Finally, we'll see end-to-end demo.
Okay.
So now here I'm explaining about the tasks functionality. Try to understand that functionality. Remove, exclude all these external functionalities under. So now the task is coming to the picture inside the Snowflake when we are loading the data between source table to the target table. Here the source table is a stage and the target table is a PRS. So now how the task is going to help us to achieve our business, that is the most important thing here you need to understand first. So now I hope this workflow is clear, right? Like where the tasks is coming to the picture, why, what is the use of the tasks in Snowflake? Any doubt with respect to that? Is it clear or not? Say yes or no at least. If it's
Yes,
not clear,
yes.
just I'll
Yes.
repeat it. Yeah, okay.
Yes.
So now you know what is mean by task, why we need the task, and how these task workflows will run in the Snowflake. So now you can see tasks can also be used independently to generate the periodic reports by inserting or merging rows into the report table or perform other periodic work. So this is what I'm saying, right? If you want to run merge, if you want to generate some report, if you want to insert some data into that report table every 1 hour or every 5 hours, you can put that particular SQL query logic as part of this task and you can run this particular task and you can make it available the data into that particular table. Tasks can be chained together for successive execution to support more complex periodic processing. So this is what we have seen, right? See now here, this is not a single step, right? So first I need to make it available the data into the staging layer. Of course, just assume the data is already available in the staging layer. So now you need to do that aggregation calculations. So that aggregation calculations, it could not be always in a single step. So if you want to achieve that in a multiple steps. So if you want to achieve that in a multiple steps, you need to create a multiple tasks and you need to run that multiple tasks in a sequence manner. In a sequence manner, which means if you see here, so there is a task A is there. Once this is a kind of a root task. Once this task A is completed, then I need to trigger task B and C. Once the task is B completed, then this task D should run. E should run and F also should run based on this task B status. So now this is we called as a DAG, direct acyclic graph. So now you are running these multiple tasks in a graph manner. So that is we called as a DAG in a technical term. So now user can define a simple tree like a structure of the tasks that starts with the root task and it is linked together by the task dependencies. So this is what we are discussing here. So this task you can run independently or you can run in a chain manner by sequentially one after one. And this entire graph we called as a DAG. So now how we can schedule this task? How we can schedule this task? So now we have discussed, right? You can schedule the task. So like basically you can schedule this particular task in a two ways. One is a standard time. So standard time in the sense every 5 minutes, every 1 minute, every 10 minutes, every 30 minutes. Like if you want to give in a minutes, you can give 5 minutes, you can just give the time. But if you want to execute this particular task in a particular time frame, so that's where we called as a we'll use cron expression, cron. So what is mean by this cron expression? It is basically in Linux and Unix systems we'll use this particular method. So in this particular method when we are scheduling this, so you will see this practically demo, then you will get more clarity, but just try to understand the functionality here. So what is mean by cron means you are going to define that particular time frame. So like this particular month, this particular date, this particular time it should execute this task. So you want to define that particular time frame by using this cron expression. You are going to define. So in this cron expression we will be having a kind of a stars 5 stars. So now this first star, it is a kind of a day of the week. This is come something is like 0 to 6, which means Sunday to Saturday. So which day you want to execute that particular task? For example, if you are giving a 5 here, so 5 means every Thursday or every Friday it will execute. 5 means Friday, right? 6 is Saturday. 0 is Sun. It will start from Sunday to Saturday. So Saturday 6 means 5 means every Friday if you want to execute this particular task, you will define here as a number 5. Then you will define with the month. Every month, like it is Jan, Feb, whatever month you want. The third parameter, it will show as a, it will consider as a day of the month. Fourth, hours. Fifth is minutes. So now for example, if you are giving like this, every minute it will run. If you are not defining anything, every minute it will run. So this Snowflake time zone they will use as a UTC by default. So if you are defining as part of the schedule value by using this cron expression all 5 stars, which means system it will think, okay, you want to run this every minute. For suppose if you want to run at 2 a.m. so you are going to give, this is a minutes, this is a hours, and this is the day of the month, and this is a month, and this is a week day. So these are the 5 parameters: minutes, hours, days, week, month. These are the 5 parameters we are going to use as part of this scheduling. So now if you want to run every minute, we are going to, nothing I am giving. If you want to run every 2 a.m. so 20 at 2 o'clock, it will run every day at 2 a.m. It will automatically run. If you want to run twice daily, every day if you want to run at 5 and 5 p.m. 5 a.m. 5 p.m. with the comma separated value I can give, so that automatically system will consider and it will run every day same time whatever I have defined here. Now in June, on last day of the month at 2:30 I want to execute this particular task, which means in June 30 or June 31st, every month June 31st I want to run at 2:30. So what I'm giving here, so now like last day of the month and 2:30. So what I'm doing here, the month is June and last day, which means whatever it may be, the 30 or 31st. So ideally, if it is coming 31st, right? So it will consider as a 31st and 230. So this is the 5 stars. We will define this particular cron expression however you want based on your business use case. So now if you know these parameters, you can define the time and all. So which parameter is considered what? So if you are starting from left side, the starting one is a 0. It is kind of a minutes. It will consider always 0 to 59. The second parameter is hours, 0 to 23. Third is day of the month, 1 to 31st. Or if you're giving a L means, always it will consider as a last day for that particular month. Now the months 1 to 12, Jan to December. The last one, day of the week, which day you want to run that. So these are the two scheduling methods for the task execution. Is it clear about this task scheduling? Anybody has any queries? You can schedule the task in two ways. One is a standard time. You can define the minutes. Third one is a cron expression. Cron expression, this is the parameters we'll use for the cron expression. Yes, somebody is saying something. Yep.
So how will you write this standard time?
Standard time, you'll just give a 5 minutes, 10 minutes, that's all. Nothing. There is no particular time frame and all. I'll show in demo. You'll just schedule, you'll give in single quotes 5 minutes or 1 minute or 10 minutes, something like that you will give. So something like this. Like this. 1 minute, 5 minute, 10 minutes. If you want to use a cron expression, we'll use that cron expression here. Something like this. Using cron, whenever I want to run, I'll define the time frame here. So now, like if you are, the key points you need to remember here is, so the SQL statement must be executable on its own, which means whatever the SQL statement you are defining as part of this task, it should execute on its own, which means it shouldn't depend on any other thing. It shouldn't depend on any privileges. Like if you are defining something inside the task, it should have by default all the privileges, all the access and all. Otherwise, the task will be failure. Now the task owner must also have global execute task. So if somebody, whoever is going to execute that particular task, they should have the execute task privileges, which means you are logging into the Snowflake as a user, right? Like you are giving a username and password. So basically that particular role, whatever the role I'm going to use, that particular role should have this execute task privileges. Otherwise, they cannot execute the task. And this task can have maximum of 100 child tasks, which means you have seen the graph, right? So this particular task can have 100 child tasks, which means like A, B, C, you can go up to 100 child tasks it will allow. And the tree of the tasks is limited to maximum of 1000 tasks total, including root tasks, which means if you are giving this particular graph, this graph it will allow up to 1000 tasks. But if you're talking about child tasks, in the sense, like if you're taking a child tasks for B, only this particular layer. So for B child tasks, it will allow up to 100. But if you are seeing that entire tree of these tasks, that entire DAG, it will allow up to 1000 tasks. All tasks or tree must have same owner role, which means whatever the task you are defining as part of the DAG should have the proper owner role. Must execute alter task resume before the task will run, which means whenever you create a task, the task will be in a suspend mode automatically. Until you resume the task, it won't run by default. First time as a one-time activity, after creating the task, you should resume the task. Then as per the schedule, it will run automatically. Auto commit parameter must be set to true, which means this is by default for the Snowflake session, they will set as a true only. But if in case there are certain cases, if you not set this particular auto commit, you should make it as a true. Otherwise, as part of the tasks, whatever you are defining, it won't commit the changes. Then it will might create a deadlock scenarios, and it might cause the task failures as well. So this auto commit by default, the Snowflake environment itself will set as a true in a real-time projects. Now using a create or replace and dropped and recreated using the specified definition, which means if you want to something modify as part of the task, so you need to again use this create or replace. And if you want to change the schedule the task, if you want to change the definition of the task, definitely there is no kind of a something you can do on the spot, which means if you want to change the definition, so you can use the create or replace and you can do that. Now if you want to cancel particular tasks whatever is ongoing, like I have defined multiple tasks, and if I want to cancel the task, I don't want to execute the task, so Snowflake is providing a built-in table function we call the system dollar use task cancel ongoing execution, and will provide the task name so that the system will automatically cancel this. So this we won't use, very rarely we will touch this, but this is the kind of a these points in terms of interview purpose or in terms of Snowflow certification purpose, these are the key points in tasks area. So during interview sometimes people will ask like how many tasks will allow as a DAG. Total 1000. How many child tasks Snowflake will allow to create a for a parent task? It is a 100. So in Snowflow certification also, the high possibility they can ask these questions. Any queries? Is it clear?
Yes, sir.
Okay. So now we'll see demo to understand more on this. So now I'm just creating a sample table. So these both tables having kind of a username and date. So now sometimes like if you see in a real time, whenever we are going to office, we used to swipe the user our ID, right? So now how many employees are login or how many employees are going in, coming in or going out under. So similarly, like if you want to schedule something and you are going to capture the data and you are going to store in this particular table, so you can just assume that functionality. I'm going to schedule one particular task and I'm going to, since here I don't have any system to store the data, I'm manually giving a user and manually giving the timestamp, and just I want to showcase to you people like how this task is going to log all these entries into that particular table. So now I'm doing create or replace task name and warehouse. I'm just giving the, so the Snowflake, they have introduced recently one more feature. Without this defining warehouse also, you can create this task and the Snowflake will provide the compute power and it will take care everything. But that is not like on a real-time projects. We are not still adapting that approach because so we better than the Snowflake, we know how much task is going to be take time, because as part of this particular logic, we know what are the tables we are using and what is the volume of those tables. So if you are using a small warehouse, it is a kind of a performance bottleneck. So if you are dealing with a very huge data, I can use the big warehouse, big size warehouse. So in real time, still we are following the approach is like that computer warehouse we will define by ourselves, which warehouse it should use this task. And this is the schedule part. So I'm scheduling at every 1 minute, and this is my SQL logic. So here is a kind of a simple insert statement I have taken. So now I'm just logging these entries every 1 minute into this particular table, into user table and values. This is a very simple one. We'll start with the basic one. We'll see like a task dependencies and all. So now when I'm creating this particular task, I have created this particular task. So this is the when it is created, what is the database name, what is the schema name, who is the owner of this task, and what is the schedule time, and what is the state and what is the definition, what is the definition. So this is the demo task one, whatever I have created. And if you see, the schedule will show here, and it will show state as a suspended. So this is what I'm saying. Whenever you create a task, it will by default will be in the suspended mode. So you need to resume it as a one-time activity. Once you resume this particular task, until you suspend every 1 minute, it will run automatically. So now I'm going to resume this particular task. So how we can resume? Alter task name, resume. How I can suspend? I can put here suspend. So now I'm going to resume this particular task. So I have resumed this task. Now if you go back and check the tasks, see it is a started now. So if you give a 1 minute, it will log these entries into this particular table. We need to wait for a minute. See here I have standard time 1 minute, because if I'm giving 30 minutes or 1 hour, we cannot see that, right? We are seeing kind of a demo purpose we are using, right? So in real time, ideally, at least minimum, we'll see rare cases we'll set up 5 or 10 minutes. But otherwise, if you're calling some procedures, if you're calling some merge logics and all, we'll define at least kind of a more than 30 minutes. See that entry came. So now if you leave it like this, every 1 minute, it will keep on log entry into this particular table. So I'm not executing this particular insert statement, right? I just define as part of this task, and I have scheduled the task as every 1 minute. So now, for example, if you want to collect all the log details of that employees, so whenever we are swiping, we are going to capture the details in a somewhere. So from that data, I'm going to execute this particular insert, and I'm going to insert the data into that particular table. So since I don't have any source system here, I'm just manually giving the values. So now if you see, like this task will run every 1 minute, and it will make an entry into this particular table. Is it clear so far? Any doubts?
No, sir.